In order to understand the idea of ions, we first need to understand about valence electrons. Electron in the highest occupied energy level of an element's atom is called valence electron. As you can see in carbon atom electron configuration of 1s2, 2s2, and 2p2, in the carbon atom, the atom's energy level has 2 electrons, which are called valence electrons. Valence electron largely determines the chemical properties of the element and is also related to the group number. To find the number of valence electrons in an atom of a representative element, simply look at its group number. For example, the element of group 1A all have 1 valence electron corresponding to the 1 in 1A. Carbon and silicon on the other side in group 4A all have 4 valence electrons. Next, we will talk about electron dot structure. Electron dot structure is the diagram that shows the valence electrons as dots. For example, hydrogen has 1 dot because it has 1 valence electron. Magnesium has 2 dots because it has 2 valence electrons. The number of electron dots for group A's element structures correspond to the group number. To move on to the formation of cations. An atom's loss of valence electron produces a cation, or a positively charged ion. So loss means positive, and you can see as the image show right here, this atom lose 1 more electron to form a cation. The ion of metals, also called the cations, have very similar name to its original atom. For example, this is the original sodium atom, then this is its ion, which is called the sodium cation. Likewise, a calcium atom, Ca, forms a calcium cation, Ca2+. Although the names are the same, there are many important chemical differences between metals and their cations. Sodium metal, for example, reacts explosively with water. By contrast, sodium cations are quite unreactive. As you may know, they are a component of table salt, which is NaCl, a compound that is very stable in water. Next, let's discover more about the formation of cations. In order to fully understand how cations are formed, we'll go through 3 steps, which are the electron configuration, the energy level diagram, and the electron dot structure. Let us begin with a very typical atom, sodium. Sodium has the electron configuration of 1s2, 2s2, 2p6, and 3s1. As you can see, on the energy level 3s1, after the loss of 1 valence electron, it became a sodium cation with the energy level diagram look exactly like that of neon. In order to simplify what I just said, you can see after receiving 1 extra electron, sodium becomes sodium cation with an electron configuration of 1s2, 2s2, and 2p6, which made a complete octet in the highest occupied energy level. We can write an equation to represent this process. Sodium atom with 1 valence electron, the loss of valence electron and ionization created sodium cation and an extra electron. Next, let us talk about the unusual pseudo-noble gas electron configuration. Some ions formed by the transition metals do not have the noble gas electron configurations, Ns2 and P6, and are therefore exception to the octet rule. Silver, for example, had the electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, and 5s1. To achieve the structure of Kirton, which is a preceding noble gas, a silver atom would have to lose 11 electrons. To acquire the electron configuration of xenon, which is the following noble gas, silver would have to gain 7 electrons. Ions with a charge of 3 or greater are uncommon, and these possibilities are extremely unlikely. Thus, silver does not achieve a noble gas configuration. However, if silver loses its 5s1 electrons, the configuration that results 4s2, 4p6, 4d10 with 18 electrons in the highest occupied energy level and all the orbitals filled is relatively favorable. Such a configuration is known as a pseudo-noble gas configuration. Therefore, silver will form the pseudo-noble gas electron configuration by losing the 5s1 energy level to become silver cation. Poor silver. Other elements that behave like silver can be found at the right of the transitional metal block. For example, copper can be copper cation by losing one of its electrons. Next, we'll study about the formation of anions. An anion is an atom or a group of atoms with a negative charge. The gain of negatively charged electrons by a neutral atom produces an anion, so the gain of an electron will produce a negatively charged ion called an anion. As you can see as the graphic right here, this is an example of an atom receiving one more electrons to become an anion. The name of anions, in contrast to cations, are not the same. Its name is typically ends in "ide," spelled I-D-E. Having relatively full valence shells, atoms of non-metallic elements attain noble gases electron configuration more easily by gaining electrons than by losing. Let's see one of our very first example. Oxygen. Electron configuration is 1s2, 2s2, 2p4, which has 8 electrons in total. After receiving 2 more electrons, it became oxide, giving it an electron configuration of 1s2, 2s2, and 2p6. The 2s2 and 2p6 create an octet to oxygen, which is the same as an neon atom. As you can see on the electron level diagram, the electrons in the 2p4 energy level gain 2 more valence electrons to become full. We can simplify the process by this equation. Oxygen with 6 valence electrons gain 2 more valence electrons to form a complete octet of an oxygen with 8 electrons. The atoms that are produced when atoms of halogens gain electrons are called halide ions. Let's do one example of chlorine. Chlorine had the electron configuration of 1s2, 2s2, 2p6, 3s2, and 3p5. After gaining 1 more electrons, it became chlorine, with the electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6. 3s2 and 3p6 create a complete octet in the highest occupied energy level. As you can see on the energy level diagram, 3p5 energy level, 1 more electron is gained in order to complete a complete octet of 8 electrons. We can simplify this whole process by an equation. Chloride with 7 valence electrons gain 1 more valence electron to become chlorine with a complete octet and the highest occupied level. Valence electrons are the electrons on the highest energy level of the atom. There are two types of ions, cations and anions. Cations are positively charged ions created by the loss of electrons of an atom. Anions are negatively charged ions created by the gain of electrons in an atom. Ions have many uses in our daily lives. For example, sodium hydroxide can be added into soap or detergent to wash clothes or hands. Sodium hypochlorite and sodium hydroxide can be added together to create bleach, which consequently give us awesome white clothes. Thank you for listening.